Astronomers stopped looking for life on Earth-like planets a long time ago. The places they're looking now are stranger. Most of the solar system is dead. We know that. But somewhere in this list of 12 places, the next major discovery is almost certainly hiding. Some are obvious, some are absurd. One has changed the definition of habitable in the last 6 months, counting down from the most likely.
First, Europa, Jupiter's icy moon. Twice as much liquid water as Earth, locked beneath an ice shell 15 to 25 kilometers thick. Below that ice, a global ocean 60 to 150 kilometers deep, the largest body of water in the solar system. Above the rocky core, modeling suggests hydrothermal vents, the same chemistry that on Earth is the textbook prerequisite for life. The Europa Clipper is on its way, launched October 2024. Earth flyby this December for a magnetometer calibration. Jupiter orbital insertion April 2030. 49 close flybys of Europa. It will not look for life. It cannot. It looks for habitability, ice thickness, ocean composition, organics, energy sources. Of every place on this list, Europa is the one with the most science already on its way. 2. Enceladus, Saturn's small icy moon, and the only world where we have directly sampled an alien ocean. Cassini flew through the plumes between 2008 and 2017. Salts, hydrogen, methane, carbon dioxide, ammonia, hydrogen cyanide, the prebiotic Swiss Army knife. In 2025, fresh grain reanalysis added more organics still. The molecular hydrogen alone at the concentrations measured is enough food for methanogens, if methanogens are there. We have not gone back. The next mission is a concept on a decadal survey wishlist, but of every list of biosignatures we have, Enceladus's is the longest. 3. Titan, Saturn's largest moon, hazy, orange, frozen. The only other place in the solar system with stable surface liquid, but the liquid is not water. It is methane and ethane. 2 habitable zones on the same moon. On the surface, methane lakes, weather, prebiotic atmospheric chemistry. Last year, a NASA-led team showed methane mist droplets falling into those lakes can form bilayer vesicles, the same membrane structure that wraps every cell on Earth. The first plausible mechanism for protocells in liquid methane. Beneath the surface, 50 to 100 kilometers down, a salty water ocean. Dragonfly, a nuclear-powered rotorcraft, launches July 2028 and lands in 2034. We are going. Titan is the only candidate where the search splits. Water life and methane life are both on the table. 4. Mars. The surface is dead. Too cold, too dry, too much radiation. But beneath it, the picture changes. A 2024 reanalysis of seismic data from the InSight lander modeled enough liquid water trapped between 11 and 20 kilometers deep in Mars's crust to fill a global ocean 1 to 2 kilometers deep. A continent of water locked under a continent of stone. Whether any of it leaks toward the surface, whether the seasonal streaks called recurring slope lineae are briny seeps or just dust avalanches, is still open. Mars is no longer the headliner. It is not off the list. 5. Venus. The surface will melt lead. But 50 kilometers up, in the cloud deck, conditions are surprisingly Earth-like. At 48 to 60 kilometers altitude, temperature around 30 degrees Celsius, pressure 1 atmosphere, the only place outside Earth where a human could briefly, with a sulfuric acid suit, survive without a pressure vessel. In 2020, a team announced phosphine, a possible biosignature, in those clouds. The detection has been disputed and reconfirmed, and disputed again. In 2024, a different team added tentative ammonia. It may be life. It may be unknown abiotic chemistry. The principal investigator's own estimate, 10 to 20% biological.
80 to 90%? We do not know. Venus is the only candidate where the question is still, did anyone even find the signal? 6. Triton, Neptune's largest moon. Frozen, distant, and the only large moon in the solar system that orbits its planet backwards. The retrograde orbit means tidal heating. The density implies radioactive heating. The active geysers Voyager 2 photographed in 1989, 8 kilometers high, imply something is still happening. A subsurface ammonia water ocean is the simplest explanation. It is not a measurement, it is a model. We have not been back since 1989. There is no funded mission going. Triton is the long shot, and almost certainly a captured Kuiper Belt object. 7. Ceres, the largest body in the asteroid belt, and one of the wettest by mass. The bright spots in Okata crater are sodium carbonate salts. They were left behind when briny water erupted from a 400-kilometer wide reservoir 40 kilometers below the surface within the last few million years. That is the first confirmed cryovolcanism on a dwarf planet. Ceres also carries organic molecules in 2 other craters. It is not an ocean world today. It was a wet dwarf planet 2.5 billion years ago. Ceres won't be the discovery, but it tells us how common briny dwarf planets used to be. 8. Pluto. Yes, Pluto. The planet you grew up with, the thing we demoted, has an ocean underneath it. 40 to 80 kilometers thick, slightly saltier than Earth's seawater, modeled to have persisted since the moment Pluto formed, kept liquid by ammonia antifreeze and an insulating layer of clathrate ice, trapping heat from radioactive decay. We know this from New Horizons imagery. The tectonic features, the suspected supervolcanoes, the strange unbalanced load of Sputnik Planitia. The ocean is the cleanest explanation. If Pluto has an ocean, every body its size out there might. 9. The asteroid samples. Bennu returned by OSIRIS-REx and Psyche ahead of us. 121 grams of Bennu came home in September 2023. In the dust, 14 of the 20 protein amino acids, all 5 nucleobases of DNA and RNA, bioessential sugars including ribose, a 15th amino acid, tryptophan, never before detected off Earth. The amino acids are racemic, equal left and right-handed, the opposite of Earth biology, which is overwhelmingly left-handed. That is the tell. They formed without life. These are not candidates for life. They are proof that chemistry came preloaded. 10. Mercury, the closest planet to the Sun, hiding water ice in pockets that have not seen sunlight in billions of years. Mercury's axial tilt is 2 degrees. At the poles, the floors of certain craters are permanently in shadow. No sunlight ever reaches them. Their temperatures hover near -170 degrees Celsius. In those craters, water ice. First detected by Earth-based radar in 1991, confirmed by the Messenger spacecraft in 2012. Some deposits show a thin organic-rich coating, possibly delivered by comets, possibly something else. It is not an ocean world. It is a paradox, closest to the heat, holding the coldest unswept places a spacecraft has ever measured. Whatever is hidden in those craters has been undisturbed for the age of the planet. 11. The moons of Uranus. Miranda, Ariel, Umbriel, and the candidates almost no one talks about. A run of papers in 2024 and 2025 makes the case that all 5 major Uranian moons could host present-day subsurface oceans. Miranda is the wildest case. Modeling its bizarre patchwork surface, the moon looks shattered and reassembled, points to an ocean at least 100 kilometers deep, beneath an ice shell, no more than 30. For a moon 470 kilometers across, that ratio is extreme. We have not been back since Voyager 2 in 1986. The next visit is not until the 2040s, at the earliest.
The flagship mission has been recommended. Funding has not been committed. We will not see them again before mid-century. 12. The dwarf planets we have not named yet. Eris, Sedna, Quaoar, Gongong, and the ones still in shadow. Last year, the James Webb Space Telescope detected fresh ethane ice on Sedna, a body so far from the Sun that the radiation should have destroyed that ethane long ago. Its presence implies that internal heat is still resupplying methane to the surface through cracks. A potentially habitable past. A frozen record. The same chemistry shows on Quaoar and Gongong. Most of these oceans, if they ever existed, are now solid ice. But once, briefly, they were liquid. We do not know how many of these bodies have hidden histories like this. We will, and soon. Of the 12, the 3 with the strongest case for present-day life, Europa, Enceladus, Triton, in some order. Europa, because of the volume and the active mission. Enceladus, because we have already sampled the plume. Triton, because the chemistry is alien enough to matter even if water life isn't there. Europa Clipper arrives in 2030. By 2031, ice thickness, ocean composition, and the basic question of habitability will be answered, or pushed deeper into the moon.
I'm building a channel for people who want to know what we actually know about the universe, not what makes a thumbnail pop. Subscribe if that is you. Next week, a single number that changed cosmology and why 2 teams of physicists won't agree on it.